Hi guys, how the topic is differential equation. Here you can see different orders of differential equation, first order and second ideas are in differential equation definition. A differential equation is an equation containing the derivative of one or more dependent variables with respect to one or more independent variables like this. So second order differential equation, first order differential equations. Classification by types, ordinary differential equations. If a differential equation contains only ordinary derivatives of one or more dependent variables with respect to a single independent variable, it is called to classification by order. The order differential equations only use order of the highest derivative equation. For example, a three order, second order, first order differential equation, general form, and its order. Classification by linearity. Linear. The analysis to be linear is linear. In other words, it is the following general form. Non-linear is simply one that is not linear. Linear. For example, y minus x dx plus 5x dy is equal to 0. Y minus x plus 5x y is equal to 0. Which are linear extension likewise linear second order differential first order ordinary linear differential equation. Ordinary differential equation does not include partial derivatives. A linear first order equation is an equation that can be expressed in the form dx px y q via p and q. Separable variables, the first order differential equations dy by dx f(x) is called separable provided that f(x) can be written as the product of the function of x and function of y. Suppose we can write the previous equation as dy by dx of x h of y. We then say we have separated the variables by taking h of y to the LHS. The equation becomes 1 over h of y dy is equal to gx dx. Integrating, we get the solution as 1 over h by dx, where c is an arbitrary constant. Homogeneous equations define a function of xy is said to be homogeneous of degree n in xy if f of t x t y x n f for all t x y. Examples, these are the examples of homogeneous equation. A first order differential equation is which our degree of order is once called homogeneous x and a function of x and y of the same degree. This is called in the form of dx y f of x y. The substitution y is equal to vx converts the given equation into variable separable form and hence can be solved. Note that v is also a new variable. Working rule to solve a HDE: put the given equation in the form equal check m and n are homogeneous function of the same degree. Let y equal to zx. Differentiate y is equal to zx to get dy by dz, z plus x dz by dx. Put this value of dy into 1 and solve the equation of z separating the variables. Replace z by y x and simplify. Exact differential equation. The first order differential equation is called an exact differential equation. The solution is given by integration of m dx plus m dy is equal to c terms free from x. Solution is m of dx plus n is equal to c. A constant term is 2 by y dy is equal to c x y plus 2 part of y is equal to c. Integrating factors. Definition is if on multiplying by v x y the d m dx plus n dy is equal to 0 becomes an exact differential equation. We said that in integrating factor. Rule number 1. Integrating factor is a function of f(x) alone. Is an integrating factor of the given differential equation. Another dx plus n dy is equal to 0. Rule number 2. Integrating function is a function of y alone and we use m, and a function of y alone then we use e over x is an integrating factor of the given differential equation. Rule number 3. Given differential equation homogeneous 1 over mx plus ny is equal to mu and integrating factor of the given differential equation m dx and dy is equal to 0. And rule number 4 equation is of the form of f of 1 xy y dx of f of 2 xy x dy is equal to 0, then mu is equal to 1 over mx minus ny. Rules to solve a linear differential equation. First, write the equation in the standard form. Second, calculate the integration function used by the formula is equal to exponential of px dx. Third, applications, cooling, warming law. We also see in section 1 that the mathematical formation of Newton's cooling law, and this is a equation of cooling laws. These are the applications. In series circuits, we also use differential equation in series circuit like dt by dr of dt of t. Since I is equal to dq by dt, it can be written as r dq by dt is equal to e. And other application of original differential equation is the modeling with first order equation, Newton's law of cooling, electrical circuits, no damping, light damping, heavy damping, and computer exercise for activity. Examples of PDPDs are used to model many systems in many different fields of science and engineering. Important examples: Laplace equation, heat equations, wave equations. Laplace equation is used to describe the steady state distribution of heat in a ball. They are also used to describe the steady state distribution of electrical in a ball. This is the equation of the Laplace equation. A heat equation to function is used to represent the temperature as a time t in a physical body at a point with coordinates x or z. Alpha is a temperature. It is sufficient to consider the coordinates alpha equal to 1. Wave equation, the function ux or z is used to represent the displacement at a time t of a particle whose position is x or z. The constant c represents the propagation speed of the wave. Physical application, its velocity, as we know, the displacement by velocity, acceleration, velocity by time is acceleration. If however the body its velocity v ds by dt or v d is in form of acceleration. Newton's second law is a rate of change in momentum and by a moving object is equal to the net force applied to it. The mathematical form F is equal to dv by dt is F is equal to m. Newton's law of cooling. The rate of change of temperature of an object is proportional to the difference between its own temperature and the temperature of its surroundings. Therefore, this is here theta is theta. So please subscribe my channels for more videos. Thanks for watching.